What's going on, guys? So I think, what do you guys think about this setup? I think it looks much better. I think seeing me, I don't know, just makes the video look better. Not because I'm handsome or anything like that, but the iPad itself is not as stretched out as it should be. Let me lower this real quick so I don't sound too loud. But the iPad isn't as stretched out, and I think the text looks much better. So anyways, let's take the derivative of this function here. A lot of people get confused with this when they're first learning derivatives, but it's fairly easy. So when you see the squared, when you see a cosine squared x, what's going on here is that there are two cosines that are actually being multiplied by each other. And when you have two of the same things that are being multiplied by each other, you actually have something that is squared. So let's rewrite that because you'll see that it looks much easier. In cosine x and then squared. So this is something that we've done and that you've done multiple times. So pretend the cosine x is not there. It could have been x squared. It could have been an x right there instead of cosine x. You know how to do that. You can use the power rule. In this case, because it's cosine x, we're going to need to use the chain rule. So let's go ahead and use power rule first because we have an exponent with parentheses. And using the chain rule, the power rule first, is 2 times cosine x. We rewrite the inner function. And then, of course, 2 minus 1 using the power rule is just 1, so we don't need to rewrite that exponent. And then we're going to have to multiply by the derivative of cosine x. Take the derivative of the inner function, that is the chain rule, of course. And then that is going to actually give us negative sine x. The derivative of cosine x is negative sine x. So let's put the negative on the outside. Let's multiply by cosine x. And then sine x, of course, because that was the derivative of cosine x. Of course, the negative is already on the outside. And this is our final answer.